waiting for the gates.
Hello everyone. I S. Rangeshwaramma, Assistant Professor, Department of EC, Gates Institute of Technology. A very warm good morning to one and all. I heartily welcome all the participants and speaker for the Day-3 session on the topic 5G and its revolutions. Now I request Dr. Anantagupta sir to introduce Day-3 speaker Dr. K. Krishna Naik sir. Sir, please.
Good morning, sir. Good morning to everyone. I, Dr. M. Anantagupta, Associate Professor, Department of ECE. Dr. K. Krishna Naik, sir, is currently working as an Associate Professor and Head of the Department at Electronics and Communication Engineering at Indian Institute of Information Technology, Design and Manufacturing, Kurnool. Sir, as a senior member of IIITDM, Sir worked as an assistant professor in the Department of Electronics Engineering at the Defense Institute of Advanced Technology, DRDO, Pune. In 2002, Sir has received a graduation degree in the stream of ECE from Sri Krishna University, Anantapuram, post-graduation with specialization in wireless communications and computing from Indian Institute of Information Technology, Allahabad, in India 2004, and doctoral degree from Jawaharlal Nehru Technological University, Anantapur, India from 2010. His current areas of interest includes the global navigation satellite systems, underwater communications, wireless and mobile communication systems, and electronic warfare applications, software-defined radios, and wireless networks, and indoor navigations and mobile and ad hoc networks. Sir has published 40 plus papers in national and international journals, and Sir has successfully completed 6 funding projects and presently running 4 funding projects. Sir received the Best Teacher Year of the Year 2016 from Defense Institute of Advanced Technology, Pune. Thanking you, sir.
Thank you, Anantagupta sir. Sir, I welcome Sir Krishna Naik sir. Now the session is yours, sir. Please proceed, sir.
Okay, good morning, Shri Imtiaz, ma'am, other people assembled over there. Thank you very much for giving me this opportunity. First of all, I would like to thank late Sri Sudhir Reddy sir, ma'am Padmavati ma'am, Sri Raghunath Reddy sir, and other friends at the Gates Institute of Technology, Gutti. I would like to thank as alumni of that institute. So I'm very happy to present today on behalf of Gates Institute of Technology, Pune, as I started my career from there. Today, I'm speaking about the 5G and its revolution. How exactly this 5th generation communication is going to happen. I would like to ask over there, anybody will be there all the time?
Yes, sir. If any queries are there, we will tell at the last end of the session. We will let you know,
during presentation also, please observe it's exactly going or not. Due to some communication loss, session should not be affected. Okay, ma'am?
Yes, sir. The technical team is present, sir.
Yes, thank you. Thank you very much. You are able to see I'm writing something?
Yes, sir. 5G and it's, yes, sir.
We are writing something on the board.
Yes, sir. Red, with red. You have rubbed it, sir?
Okay. Yes, ma'am. Thank you. Thank you. So what exactly, first of all, let me make understand the audience, whoever attending today or later as you are streaming on YouTube, whoever watches this video, whoever follows this video, I would like to make them understand, first of all, what exactly the communication means in the name of wide communication, wireless communication, first of all. So first of all, what exactly the difference between wired communication and wireless communication? Let us understand that two things. And wired communication, wireless communication. So now we know that the wired communication means there is a physical medium will be there between transmitter and receiver. Generally, there will be a bidirectional communication generally happens if there is a bidirectional communication. At that point of time, there will be a transmitter and again there will be a receiver. There was a phone call, I don't mind. So there should be bidirectional communication between the transmitter and the receiver and the receiver and the transmitter. So then only the generally communication happens. When this communication happens, then we divide this entire communication into two forms, either wired communication and wireless communication. So wireless communication again two types again. One is that half duplex and full duplex. Generally, full duplex means there will be two half duplex, one half duplex one side, another half duplex other side. Generally, we need to have the two half duplexes from both the sides. So if it is a wireless communication, then we have to see that the communication happens without a medium. Generally, again, happens without a physical medium. So then we have to distinguish what is exactly the requirement of wired communication, wireless communication. People may get some sort of confusion that how exactly this wireless communication occurs. Generally, wireless communication occurs with the help of a electromagnetic signal. When electromagnetic signal, generally we transmit with the help of a transmitter. Then similarly, we receive the same signal from the receiver. whatever the signal which is transmitted. How exactly it happens? Let me draw the same figure again. Based on the aperture, the signal will go like this. Without signal, it affects there and it may be coming inside the waveguide. So antenna. So now this is the transmitting antenna. This is the receiving antenna for the half duplex. If it is a full duplex, then obviously here there will be a transmitter and there will be a receiver. Based on this nature, whenever the half duplex signal will be one side, another half duplex signal will be other side. The signal can be transmitted in both the direction. But we have to understand how exactly it happens. It is the waveguide and it is the waveguide. Here it is the free space. So now here the information, electromagnetic information will be in the form of electrons, in the form of holes. Then again, whichever the holes will be observed, the rest of the signal only will enter again in the form of electrons. So now we have to understand how this scenario, whatever the signal which is reaching to the respective receiver, depends upon radiated energy. This radiated energy again, it depends upon the type of antenna we will be using. Type of antenna will be using. Let me make another slide here. Madam, you are able to follow? Madam Ji?
Yes, sir.
You are able to follow?
Yes, sir.
My slides are visible?
Yes, sir.
Yes. So now let us see the type of antennas here. So antenna is basically a medium or conductive material which is having conductivity the conductive material which will be used as a transducer. This is a transducer. So transducer means same antenna can be used for transmission as well as reception, both. So when we are using the same thing here, it is basically the transducer which can be used for the same antenna can be used. It will convert from electromagnetic energy into the normal energy or electromagnetic energy which is required for the amplification. So it converts the respective electromagnetic energy to normal, only the electromagnetic signal to the normal signal, and it collects whatever the signal which is incidenting onto this particular transducer. So it converts the signal from the free space to the normal, the respective medium. When it is happening again, this is having the two types. First one is directive, another one is non-directive. One is directive, another one is non-directive. So directive means it's a completely a directional antenna, and non-directive means it's an omnidirectional antenna. Specific angle, and here 360 degrees. So generally for communications we use both the directive as well as the non-directive. Directive antennas as well as omnidirectional antennas. Then when we are using type of communication we need, for the long distance communication, generally we use the directive antennas, and short distance communication we use omnidirectional antennas. So now the communication need to be classified into three types here now. One is that long distance communication and medium distance communication and short distance communication. When we use this long distance, medium distance and short distance, generally these two will be non-line of sight. Off to the antenna. This will be in the line of sight. Line of sight of the antenna. Based on these two requirements, we will try to make use of the wireless communication in the form of long distance communication, medium distance communication, or short distance communication. The long distance and medium distance can be non-line of sight, and the short distance communication will be line of sight communication. Based on this one, now we are trying to classify the respective communication into different forms as of now since existence. Basically it has started from communication. Initially it was an analog communication system. Currently we are using completely digital communication system. Digital communication system. Generally in analog communication, analog signal with analog carrier, but in digital communication, digital signal with analog carrier. So these two are the analog communication systems as well as a digital communication system. Whenever the free space, obviously all signals will be in analog in nature, but olden days within the system also there was analog system. Now these days we all are using digital systems. When we are using both the digital systems, then we have to make use of both analog signal to the digital analog to the digital conversions as well as digital to analog conversion, depends upon type of system we are using. By looking at this entire concept of past these two slides, now I would like to explain how exactly happened as of now in the generation or evaluation of the communication systems. As of now, we are going to experience very soon. Still it is because there is no specific standard for the 5G communication. The 5G communication is one of the hypotheses based on the performances, whatever performances we try to exercise. Based on our exercises, we try to make use of the communication system. Madam, you are able to see the slide?
Yes, sir, it is visible.
Yes. So, based on the communication system we are using, as of now, the 5G communication system is not at all a communication system. It is completely using the advantages of each and every requirement of the communication, simply extending the data speed, extending the capability, extending the facilities. So now basically if you look into this figure, first of all, I would like to give all the credits to some sort of the graphical design makers, whoever have made these slides, because I have taken this one from the open source. I would like to give all credits to them because I have taken from them, from the internet sources. I would like to give due credits to them. Thank you for them for making this available on internet. I'm directly making use with these credits to them. Let us look into the first generation. It was completely an analog telephony. We used to call analog wireless telephony. Completely analog wireless telephone. It's purely analog to communication. System also an analog signal. Then transmitter also used to analog signal. Receiver also used to receive the analog signal. And demodulation also, complete analog wireless telephony we used to call it. So completely analog system, that's what it is, a 1G communication system. After that, we would like to have some sort of changes into the communication mode. Not only the distance, for primarily we would like to have the long distance communication. Then we would like to have the more number of users, the more number of people, and more distance to be occupied, more distance to be provided with the communication system. Not only with that, the device size also need to be reduced. Originally, the device size of the analog mobile phone system was very brick size. From that to the palm size, it need to be brought. So it was perfectly brought to the palm size. One important thing was there, it was completely made with the 64 kbps, only 64 kbps and 160 characters of information transfer in the name of SMS. So when it is SMS was there, it's very 160 character we used to transfer, and based on this particular message, we used to be happy. At that time, the mobile phone system was it was sometimes the LCD displays. There used to be 7-segment displays as well, and we people used to use very different kind of the mobile phone system. Slowly, the second generation was also referred as a digital telephony system. So when this digital telephony, from that, the enhancement of the digital communication has started, and we refer it as any digital system of communication, and people refer this as a second generation mobile communication system. After that, when people have studied, when the people wanted to make very much brighter system of this one, then again system came into two types again in the name of, initially 2G was in the name of Global System for Mobile Communication. It was called Global System for, initially it was a group special mobile, later it was referred to the Global System for Mobile Communication. After that, it was made lot of changes, distance wise, number of users wise, at the same time the screen size and device size and device application, including multimedia messaging services. That was brought to the third generation. So it's called multimedia service provider. And here two kinds of technology were adopted. One is 2G or 2.5G. 2.5, these two were merged, and finally 3G also. So now in system has made from the SMS to multimedia services. Based on this particular multimedia, whatever the multimedia transmissions, multimedia receptions, multimedia creations were made available, and we call this facility were as part of a smartphone. Based on this particular device, same device used to provide the services of GSM plus CDMA as well. Initially, these two were separate. Then later on, these two were merged. When these two were merged, and successfully it was going on, then people have moved towards some more enhancement of the smart system. Not only that one, it carrying more data. For initially, you can see here 2000 kbps to the 1 Gbps. That's only the variance, the excellent change was, and it was called the live information, different contents, and applications of not only communication, other applications also can be used by using this particular generation. That's why we call it as a fourth generation communication system. This fourth generation communication system we are experiencing today, 99% of the mobile phone users have experienced this fourth generation communication system. As part of this fourth generation communication system, the data speed is generally available of 1 Gbps. Not only 1 Gbps, it can also transfer the live streaming. It also may provide the various type of the multimedia applications, and the device applications also can be embedded with the fourth generation communication system. For that, it was called, for third generation, we call it 3GPP only. This also 3GPP with additional to long-term evaluation and voice over IP. And we call it as a VoLTE. Technology called VoLTE, and we call VoLTE. So it's basically voice over long-term evaluation, voice over internet protocol, and it's extension of third generation partnership project, and we refer it as a fourth generation communication system. As of now, we have just seen increasing the data speed from one generation to fourth generation, starting with 2.4 kbps to the 100,000 kbps. 100,000. So when we look at up to the 1G speed and including all multiple, what rest is required? What exactly required for us? The required for us is that simply we can say that the fifth generation communication. As of now, 4G, it is completely the public telephony, completely a public communication system. But people are interested nowadays, would like to have their own private communication system. When they would like to have the private communication system, the current fourth generation communication system is not providing that facility. I would like to make my system, it should be useful for me personally. Whenever I require, it should be public connection also. To achieve that particular one, the fifth generation communication was made and providing the services of the both the public service as well as the private service based communication system, and increasing beyond 1 GB and up to 60 GB we are trying to expect as part of fifth generation communication system. As part of this, my dear friends, we are going to minimum requirement of our future. We will be using various requirements with the help of Internet of Things, and as we are connected from many places to many places by using the high-speed internet provision. That high-speed internet provision, as I said, that more than 1 Gbps and up to 60 Gbps provision is required. And it should be of the ultra high definition. The video capability also need to be transferred as we are achieving up to 60 GB. When it is happening like that, then we have to look into that real world applications like AR and VR. By using these applications, we are trying to make use of the communication system in the name of the fifth generation communication system. Now, this is the advantages and disadvantages of the technology differences between the first generation 1G to 5G. Let us see that one. First generation was made during the 1970 to 1984. Then second generation was, because you can see here, 1984 and 1980 started, because overlapping will happen, because then only the obsolescence of the old technology will happen. So for some time we keep hand holding of the old technology because devices will be there. So from 1980 to 1999, it was 2.52G and 2.5G. Then it went to the 3G. Then it went to 4G. So you can see the same, the differences. The 1990 to 2002. And 2000 to 2010, so 4G has been into the existence. So you can see the 2 kbps, 64 kbps, 2 mbps, 200 mbps to 1 GB. So wireless communication, cellular communication, and the mobile communication. Wireless communication means both the transmitter and the receiver are fixed. Both are fixed. In cellular communication, there is a transmitter and there will be a receiver. This fellow, the receiver, will move within the cell. In mobile communication, the same concept, but there will be multiple transmitters will be there, and the mobile users can use from any place to any place among all the cells. So now here we have made that, because the cellular communication is not only one base station, there will be multiple base station. User will move from place 1 to place 2. So it's not completely wireless communication, because the changes will occur into the wireless communication in the name of the signal propagation. When signal propagation makes a lot of changes, then the issue will come. So to achieve that one, we call it as a mobile communication. Signal systems will be moving from place 1 to place 2, one base station to another base station, and his communication will be continuously operational. So in that particular context, we refer it as a mobile communication. So now the difference is the wireless communication, both the transmitter and receiver will be fixed. Cellular communication base station will be fixed. Mobile user will be mobile, but within the cell. But mobile communication base stations will be fixed. The users can move from one cell to another cell based on total number of cells, any place to any place, if the service is made available. So accordingly, now the cellular telephony as well as the digital.
Sorry to disturb you, sir.
Yes.
Sir, PPT is not visible, sir. Please present the screen, sir.
So how long it was not visible? Imtiaz? Hello?
For last 1 minute, sir.
Last 1 minute, huh?
Yes, sir.
Okay, no problem.
Yes. Thank you, sir.
Now, Imtiaz?
Yes, sir. It is visible right now, sir.
Yeah, I'll again explain that. The wireless communication, cellular communication, and the mobile communication. So wireless communication means both the transmitter and receiver will be at the fixed location. They will not at all move from place 1 to place 2. Obviously, these two will be in line of sight or non-line of sight. But cellular communication base station will be fixed. Mobile user will be moving within that particular cell only. If it moves out of the cell services, services will be disconnected. Mobile communication, there will be multiple base stations. By using these particular multiple base stations, user can move from place 1 to place 2, and their connections will not be disconnected within the respective base stations when they are moving from place 1 to place 2. So accordingly, we distinguish the communication into the form of, say, wireless communication, cellular communication, and the mobile communication. And this technology we refer it as in this particular form. So now the fourth generation is worldwide wireless web. Wireless World Wide Web, we refer it as, even though this is started from here, completely wireless only. The services we call it as only the mobile telephony, only for the voice communication here. Then we have used a voice as well as a short message service. Then after that, it was a high quality audio, video, and we refer it as a multimedia services. Then dynamic information access, any information can be accessed by using, including World Wide Web, that too wireless. So now it is, if you look into the technological requirement of the frequency division multiple access, time division and the code division multiple access. As I said, the third generation was completely the CDMA only, and this was the CDMA. Currently, we will be using the CDMA technology. The switching is previously only the circuit switch. Now his circuit as well as the packet switch, packets, and the packet. So here the circuits and the packets both were there. And the core network generally used to happen here as a public switch telephone network. Basic, it was olden network where used to have the landline phones as well as the wireless phones. Together is what we call public switch telephone network, is a backbone network. Now the same thing, public switch telephone network here, public switch telephone network, and we call here the packet network, internet obviously it is a packet, and that too World Wide Web with wireless in nature. The handoff generally used to happen here currently. So, for example, mobile phone to GSM to GSM, GSM to CDMA to CDMA, Bluetooth to Bluetooth, Wi-Fi to Wi-Fi. Currently, it is we refer it as a horizontal handover. But now the fourth generation, we are trying to make use of little bit vertical also involved, and here both horizontal and vertical both will be there in the fifth generation communication. So same thing is given here as in a detailed form. The developed in 1980s and the based on analog system 2.4 kbps, and we used to refer it as advanced mobile phone system, and allows to make use voice within a place. Basically, it's basically cellular communication, pure cellular communication system. Similarly, the second generation was 1980s, complete 1990s, and after that started obsolescence. So based on digital system, maximum 64 kbps, voice and chat message services, the semi-global facility, and started with the 2.5G also, and people have used extensively with the maximum brick size to the smallest size of mobile phone device as well. 3G, it was the starting of the smartphone system. It was generally increased to the 2 Mbps, and it started using the email, the digital assistants, and World Wide Web, and other applications like the e-commerce as well, including the global roaming facility was also made available in this third generation. And generally it was called third generation partnership project. Fourth generation, what exactly currently we are experiencing, many of us have used it, are using it. It was brought to the service in 2010, up to 100 Mbps, but it can go up to 1 Gbps. It was a high performance, easy roaming, and very cheaper communication system as of now. Tomorrow, when 5G comes, it will become more cheaper, but the only the disadvantage would be we need not to we can use any sort of the mobile devices. We need not to have specialized devices. In the future, the people can make use of their own system. People will use their own devices, whichever device they got, and that will happen tomorrow, including their mobile phones and their laptops, their tabs, whatever the device they got, they can make use by using the fourth generation in the name of fifth generation. So now we are here with the fifth generation communication system. It will be completely the very much smart. Advanced, you can say that advanced smart, but let me figure out as we are discussing about the fifth generation major phase of the mobile communication. It will be the next generation type. We will be experiencing more, and the 10 times more capacity than others. So the 10 times means 100 Mbps, so 1 Gbps. So expected speed up to more than 1 Gbps basically. So faster, reliable than 4G, low cost in previous generations, including the devices plus the services. Both will be cheaper. You can see this particular figure I have brought to you. We made this particular figure. Previously, up to fourth generation, it's completely horizontal handover, Bluetooth to Bluetooth, Wi-Fi to Wi-Fi, GSM to GSM, CDMA to CDMA. Now, anybody can communicate with anyone. Anyone can communicate with anyone. That's what a vertical handover. Two minutes, please. Our water break. So let us look into the standard accelerations, how exactly happened the 5G. Generally, people are calling it as a 5G as a new radio. So our next generation radio communication. So here the people have initially there was no standard. We call it as a non-stand-alone system. And it is basically originally it was called as a third generation partnership project. As part of this project, third generation partnership project, people used to refer it as the fifth release, 3G people released 15th acceleration. So as part of the 15th acceleration, we are trying to make use of this communication system in the name of 3GPP only. But we are referring, people are referring it as a 5GN, the project plan. The 5G, the new radio, or next generation radio also can be referred as. At the same time, the actual agreed plan is intermediate milestone to complete the technical specification related to the configuration called the non-standalone 5G new radio. Non-stand. Standalone means it's a completely the new radio, but it is a non-standalone. So it is completely depends upon all the previous versions as well. So previous version now currently fourth generation communication system. If you are achieving the more data rate, the more speed, the more applications, still we call it as a 5G. So based on that one, we refer it as the non-standalone 5G, and it will utilize, you can see here, it will utilize existing LTE radio world. No change, existing LTE radio and core network as anchor for mobility management and coverage while adding the new 5G carrier. So there is no separate technology is being made for the 5G. We are using the same old standalone, the technology in the name of non-standalone, the 5G new radio technology. Based on that one, we make it quickly work and market also will be using and trying to adopt the many applications which requires high speed and other requirements. So accordingly, we are making use of this particular standard acceleration. It is not a new standard. It was completely part of the 3GPP only. Advantages and disadvantages both are there. As I said that we are not at all making the new technology. It is already the old technology, but we are increasing the capability. That's only this one. The cons is basically it's a revolution approach. Sometimes it may be using the old technology. You can see here today the old technology. 5G to rely on today old technology because there is nothing new here. So same whatever the technology available in the name of the 4G, we are simply extending its capability. That's all. Nothing beyond that. You can see, my dear friends, so evaluation solutions are already happening, already there, and the name of the 3GPP. Let us see here, multi-content play, yes, we are doing it. And AR, VR, we are doing it. 5G multi-utility UE, user interface, we are trying to do it. And 5G bus, we are trying to use it, we are using it, whatever. And GNSS positioning, global navigation, satellite, yes, we are doing it. Satellite communication, we are doing it. Other applications as IoT for LoRa, IoT safety, Omni-Point, Sync View, 360 media, and 3D application. So almost everything is made available. But what exactly we are trying to do? Only the making all these together compatible, more compatible. More compatible. At the same time, more secure. Less data loss. Less. So by using all these things, we are trying to make the 5G. Then if you look into that, this has been divided, this technology, into that enhanced mobile broadband, ultra reliable and low latency communication, massive machine type communication. So these are that we have divided this one into three types. One is enhanced mobile broadband, only the data rate incremental. The second one is ultra reliable, low latency, low loss, and low increase in high speed. So low ultra reliable, so we can rely it. data loss will be very less. We can transfer as much as possible. And the third one is this massive machine type. Any type of devices can be connected by using the IoT. In IoT, we can connect as many number of possible devices. So as we are trying to make use of various devices into it, we can adopt this particular MMTC in the name of massive machine type, the communications. So based on all these requirements, you can see here the peak data rate, use experience data rate, the spectrum efficiency, more mobility, low latency, connection density, network energy efficiency, and area traffic capacity. So by using all these things, primarily we merge all together in the name of EMBB, MMTC, URL, LC. Based on all these things, you can see we have divided these requirements into these three subdivided. So finally, you can simply see here the 5G is characterized in the name of increased data rate, enhanced spectrum efficiency, and reduced latency. These three are only the basic advantages of the 5G and enhancement from the 4G. If you look into the quantified data of these three, you can see here 1,000 times higher mobile data volume in geographical area, 10 to 100 times more connected devices, 10 times to 100 times higher typical data rate, the 10 times lower energy consumption, end-to-end latency less than 1 millisecond, and acuities of 5G access, including low density areas, low or high density areas as well. So finally, we can look into the various applications which can used in the name of EMBB, URLCC, LLC, and mass MMTC. So based on all these requirements, we can try to see that. First of all, let us look into the enhanced mobile broadband, the high definition, that is ultra high definition video, augmented reality as well as virtual reality, cloud-based gaming, enhanced mobile media or multimedia, the mobile broadband television transmissions, receptions, the in-venue wireless broadband. From ourselves, we can make our own private network, in-car operations or other devices. If you look into that low latency industrial automations where you will be connecting many devices, so where you require very less latency. Remote manufacturing, surgery, and other applications, industrial and medical applications, which needs low latency communication. Self-driving or autonomous driving vehicles, we need very high speed and low latency communication and ultra reliable application. So based on this one, we need the ultra reliable low latency communication. Another one is a massive machine type. We are connecting various devices together. So for example, if you take our own home itself, our every home will be having washing machine, fridge, electrical appliances, lights, fans, and other television, other things. Everything need to be connected. So now we are connecting many massive machine type and all things need to be communicated. So based on this one, we are trying to make use of the 5G. So for that, you can look into that final heading here. The 5G connections will go beyond the human beings communication, will enable the intelligent Internet of Things in future. Currently, we are using IoT 2.0. So in IoT 2.0, it is completely AI based and we call it intelligent IoT. IoT we will call. When it is IoT, it is thinking beyond our expectations. Minutes, please. Imtiaz, slide is visible?
Sir, yes, sir, it is visible.
Thank you. Thank you. So if you look into the global perspective, where exactly the 5G innovation and how the 5G innovation has happened, basically, first of all, people used to refer it as a Huawei 5G. Basically, that has taken initiative to development the technology. So first of all, primarily, it has taken birth at the Huawei in the name of the technology with the help of ITU in the 3GPP, 5GPP, and international mobile telecommunication. So based on all these things together, primarily the different phases has built technology. But still, this is not a complete standard. People are trying to make use of the 4G towards the 5G, and as per their wins and fancies, the technology has been provided that one. That's what the beauty of the 5G. You can see here the 11 5G research content centers. 300 plus top 5G scientists and 8,000 plus R&D employees as part of the Huawei worked for this one. As part of the same thing, different countries have taken the part in making the standardization of the technology. Currently, there is no standard, but taken the part to develop the technology in different form. India also now started by initiating 100 5G labs across the country. So when status is currently, we call it release 15 and release 16. Tomorrow release 17 also will be going to come back. As of now, by 2020, it's completely, we call it a full IMT, and we refer it as a 5G NR. So previously it was non-standalone, then standalone, now full new radio, International Mobile Telecommunication Union based. So it is called the 2020 new radio. We refer it as simply the new radio. If you look into the release 15, they are used the frequency range 1, frequency range 2, sub 6 gigahertz, now completely 2.4 gigahertz to 5.2 gigahertz. So NR framework is waveform, channel coding, the frame structure, the numerology, the massive MIMO, the technology, and other technology architecture and the release. So, but if you look into the release 16, 17, 18, it has been becoming like the new radio, completely the new radio. Previously, it was standalone, but it's new radio with the help of non-orthogonal mobile phone access. So, in NOMA, basically the technology. So, it will be not purely orthogonal, it's parallel, you can say non-orthogonal. So it can be the parallel techniques can be adopted as part of the NOMA, we call UFMC. Based on this NOMA UFMC, the technology has been adopted for the 5G communication. So now, if you look into the technological architecture of the 5G, so we generally will be having the 5G core network, the 5G radio access network, the user equipment access. So this is basically 3-layer architecture. We can say that layer 1, layer 2 and layer 3. Layer 3 is a user layer, layer 2 is the network layer, layer 1 is the application layer. So basically, the network layer. So it's the application, user layer, the network layer and the physical layer. So core network. So based on that, basically the 5G core will be the backbone network, the radio access network, the base stations, and the users will be accessing from the base station. So now we'll divide this network architecture into the 5G core network, radio access network, as well as a user equipment based on the application. All application need not be similar. That is a beauty which is going to happen as part of the 5G communication, and we refer it as a 5G NR. Radio can be modified as per the device requirement. The same thing here, you can look into that. So the user equipment and the network and the backbone. So starting with the remote radio unit, the distributed unit, the centralized user plane, centralized control plane, user plane functions, session management functions, unified data management functions, authentication service function. So this is basically complete the backbone network as part of the backbone network and the network. So here we call the massive MIMO. So many kinds of transmitters, many kinds of receivers can make use of this technology so that many stations can be the micro cell, macro cell, or the large cell. So cells can be of different sizes. You can see here the macro cell radio to the smaller cell. So different kinds of transmitters and different kinds of receivers will be there as part of the front haul as well as the mid haul. Normally, if you look into the basically layered architecture with reference to OS reference model, by using the OS reference model, we know that it will be having the 7-layer reference model. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. But if you look into the 5G, this has been divided into 4 basic layers, and we call them as a application layer, service layers, other device layer, equipment layer. The open transport protocol, because different transport protocols will be used here, and we call the open, depends upon type of service we are using with the user equipment. And we call it upper network layer as well as the lower network. Lower network layer is completely the backbone lower network. Upper network based on the type of devices we use. And finally, we call it the open wireless architecture, any device to any device wireless network. So it's basically the physical network, physical layer as well as the data link layer, and we call it as a OWA, open wireless access architecture. So based on this one, finally it is a layer from the top, layer 1, layer 2, layer 3, and layer 4. We can simply say that application layer, transport layer, network layer, and the wireless layer. Wireless layer. So based on this one, we can call physical layer. There is no physical medium will be here, so we call it as a wireless layer. I have already explained this one. So network layer and the open transport layer and the application layer and application, transport, network, as well as the wireless are the physical layer. So these are the various layers. So if you look into the hardware, basically same the 5G communications, 4G communication system will be used here. So where we try to modify as per the requirement, starting from the antenna to the device requirement. It is not mandatory, but it can be, people are making these days. Many of you might have purchased, users might have purchased these days as available in the market in the name of 5G mobile phones. So we refer it as a 5G mobile units. So where it is, the exact requirements are 5G hardware and the 5G software. Uses the ultra-wideband based network with higher bandwidth at the lower energy levels. Bandwidth is of the 4000 Mbps, which is of the 400 times faster than today's wireless network of the 4G. The smart antenna we need, the technology is basically code division multiple access. If you look into the software, the reconfigurable software, current mobile phone can be reconfigured as a 5G phone. Whatever the mobile phone we are using, we all are using these days, can be modified by using some software patches installed, application installed into the mobile phone. So that is a single unified standalone of different wireless networks, including LAN, WAN, World Wide Web, and World Wide Wireless Web, and unified IP and seamless communication broadband, and software-defined radio and encryption flexibility will be also possible as part of the software radio. The features of the 5G communication system are, it can be used as a high resolution for the crazy cell phone users. Obviously, as I said at the start of the class, the bidirectional large bandwidth, less traffic, 25 Mbps minimum, and up to 1 Gbps or more than 1 Gbps. Uploading and downloading speed of the 5G, obviously up to 1 Gbps or more than. Better and faster solution. High quality service based on the policy to avoid errors, support virtual private networks, more attractive, effective networks, and the faster. So similarly, you can look into that configuration of the technology completely. 3G was the operator centric, 2G also operator centric. Now 3G is the service centric, 5G is the user centric. You can configure as per your requirement. So it is affordable, high peak feature, the much reliable network. So obviously, as 4G also are experiencing the voice over IP, and the 6G technology also can be made these days. We are connecting many IoT devices connected with our own network, our own devices. All of us are using the smart watches, calculating various health measurements. So finally, if you look into the 5G development, it basically changes the respective barrier of the difficulties, barrier of the complexities of the communication. It can allow the users to do whatever the user would like to do, create a public network, create a private network. You can increase number of users. You can configure the base station on his own with the help of the 5G technology, and we call it scalability rather than the bandwidth. Network will be heterogeneous, as I said, that vertical handover also possible. The range of many times of the access points can be, but generally one disadvantage of this fellow is the very short distance communication. Simply, it is short distance communication. So decomposing of the future technologies as atomic network will be there, and the flexibility in 5G will be, complexity in management will be reduced. So mostly 5G happens locally in our own way of the users. As I said, that is a user centric, so it happens locally. To identify this one, we need the technology concept called cognitive radio. How to make the locally, because just like that we cannot use the technology just like that. Where, as I said, that it is the not horizontal handover. As of now, it has happened only the horizontal handover. Now we have to move to the vertical handover. So now we are combining both horizontal handover as well as the vertical handover. So now any diversified the communication technology can be mixed together and can be used together. So then finally we are referring it as a intelligent radio. So for that, we need to make use of the flexibility in the mobility of the user, the connectivity of the network, usability of the application user. Whatever the application user would like to configure, he must be make use of it. How it is possible? So it need to be unique and innovative networking concept need to be created. Integration of the different type of communication network of voice and data. We have to integrate together, and wherever the requirement is there for I need the channels, more channels for the voice, I need to get it. I need more channel for data, I need to get it. There should not be any restrictions. We have to make it possible. We have to make it the mobile ad hoc network, software defined radio as well as the cognitive radio concepts with specialized addressing configuration, authentication, and security requirements. So finally, as we are trying to make it, every one of us are making use of any one of the technology, every one of the technology, more than one technology. So when we would like to, we are using, all should be vertical handover only. At any point of time, you should not be denied any kind of communication. So for example, you are user of the Airtel, you should not be, when the your service is not available, you should not deny services. What is the next service which is available? That service need to be provided to you at any point of time. So that is very short time. As part of the 5G, it is going to happen. So as part of the cognitive radio, it is basically a new architecture plan. It's architecture. So where it completely depends upon the software architecture. Waveform software, architecture services, operating system, broad APIs, and board packages. Already this is mobile phone will be available. So we have to develop these things only as part of the cognitive radio. So now we have to look into that, how it will be used. If I would like to contact someone, would like to make a call, it should be immediately call must be made. When we have to make the immediate call, obviously we must be immediately connect to the network. When we are connecting it, and people want to connect radio, something completely different. So connect radio must be involving. And second, please. My sincere apologies, please. There was a phone call. I could not. I have to attend that phone call. So if you look into that, the many definitions, the focus lost on implementation, and generally we are working with the AI, so it has to be adapted, and much focus on application. So 5G means the application. So many applications need to be adapted. So like I will show a small the video here, small animation here. So how exactly the cognitive radio generally happen in the name of generic cognitive radio cycle. Let us see here, first of all, the learning, the obtaining the knowledge and decision adjustment about the system, about the signals of the 5G or applications, who would like to connect with whom. So when obviously intelligently, the capacity should be of the purposeful goal and eliminate the some of the messes. I would like to I would like to just call cognitive radio or intelligent radio, anything of our choice. So generally I am referring it as a cognitive radio or intelligent radio, both are same. Let me make use the small animation here. So generally it is having different levels. 0 level software defined radio, the goal driven. Level 1 is a goal driven, is basically making a call. First of all, any signal is received by our system, it will be observing, it is belongs to us, it will decide and it will connect. Then it orients to the next, call it the context aware. So based on that, it will orient what kind of application it is. So in the name of the orientation. And the name of radio aware, what kind of radio it is, what is the frequency, it is a 2G, 3G, 4G, 5G, everything will be connected with that. There's a planning how to connect with what. So it will be negotiating if channels are not available, the frequencies are not available, any difficulty in connection, that also will be connected in the name of negotiating. The learning, the environment, what kind of application required to the user, how the user is moving fastly, user is moving slowly, user frequently visit the place, everything will be as part of the cognitive cycle. So for that particular purpose, it learns environment. Then adopts the respective plan. After learning the environment, it adopts the respective plan, which is the best plan, which is the best platform, which is the best location. Adopts the protocol, what exactly the protocol need to be adopted, and we call it as a best adapted protocols. So finally, we call it as a OIAD cycle in the name of the object oriented cycle. So based on that, it's basically we call it as the decision cycle in the name of the cognitive cycle. So finally, we call it as a cognitive radio with the software defined. So software will be defining what to be cognitive. So here the device we are not changing. Device, whatever the mobile phone device will be the same. Device we are not changing. So we are changing only the software. So software only will be modified, software only will be reconfigured, software only will be modified. Accordingly, the system will be created and connected. So now let us distinguish between the conventional current communication radio, conventional radio, software radio, as well as the cognitive radio. So based on that, it supports fixed number of systems, as I explained in the start of the class. Reconfigurative with the design itself need to be reconfigured, and support of multiple services, but at the time of design, everything is based on the design. At the time of design. But if it's software defined radio, it can be at any time after design. Yes, made the device, but it is not reconfigured by the user. User can reconfigure. So it completely with the user. Here, after the design only, but by the device. The user involvement will not be there. Device itself will create everything. You can see here, dynamically support multiple variable system protocols and interfaces into diverse systems to provide a wide range of services with variable quality of services. If you look into the cognitive radio, can create new waveforms on its own, can negotiate with the new interfaces, adjust operations to meet the quality of services required for the application. So it is by the device. So you can see here, at the time of design, everything need to happen. After the design, by user will configure, here device will configure everything. So now everything is cognitive by the device. Device can make their own changes as per the environment it has detected. Imtiaz sir,
Sir, yes, sir.
I have to conclude now.
Okay, sir.
No, you have to conclude in close chayala.
Sir, 5 more minutes, sir.
Okay, sir. Okay, sir.
Okay,
Thank
sir.
you. Thank you. Thank you. So accordingly, you can simply say that if you look into the design itself, the conventional, traditional design, traditional baseband design, the conventional plus software architecture, reconfigurability, provisions to easy updates. You can modify this. Everything is possible here. All thing is possible here. Here there are limitations. As I said that it is by the design, by the user, by the device itself. So it is basically by design, user, and the device. So here if you look into the update cycle, we cannot be upgraded, but here yes by the user, yes by the device. So it can be used for many applications as part of the 5G, starting with the spectrum trading and the opportunity spectrum, advanced networking, intelligent beamforming, collaborative techniques, improve the link reliabilities and connection, automated interoperability of devices and the networks. So you can see here, it can be for generally for the navigation purpose or the service application purposes can be made. So basic automated interoperability means we need not to inform that device itself connects with anyone and anyone to anyone. The spectrum trading, so it can be done. The collaborative radio, any kind of vertical handover can happen from any radio. You can see here, any radio to any radio. You can any radio. This is different radio. This is different radio. These are the different radios. Everybody having different radio. All can be connected and communicated. And we call it as a cooperative MIMO for this one automated. So for that particular one, we have to divide that the first user to primary user, secondary user, and third user can also be given services. You can simply say that source cluster, relay cluster, destination cluster. So primary, secondary, and third user. So one we call it as the transmit diversity, receive diversity as well. So for this particular purpose, people have divided the entire collaborative radio in the name of distributed processing and the collaborative processing, and improved localization as well as reduce the contention at the high speed can be made possible in the name of IEEE 802.11e. So distributed mapping and the theft detection also can be possible here. So for that particular purpose, we need to have the coverage of maps and congestion maps. So this next generation communication as part of the new radio is basically divided into two types. One is a wireless adaptable network nodes, and the wireless adaptable network nodes along with adapted development. So it can be reconfigurable to anyone. Finally, the dot pass, the wireless network adaptable network, so which is having this entire the protocol stack. So let me come to the conclusion. So you can see here, so a single device has a software-defined radio as well as a cognitive radio. So here this is completely by design, the provisions are being made. So user can make use of any technology to any technology by reconfiguring themselves. So by functioning and operating, separating antennas, cost varied, power consumption, for everything we are trying to make use as it is a different system. But we are making as a combined system. Single system is correct, is fine, as currently we are using the horizontal handover, and we are making vertical handover. Anyone to anyone can be communicated. So for that, we have to combine we have to integrate various technologies where we can have the vertical handover. So as I said, that small example is that, for example, Bluetooth is 10 meters, Wi-Fi is 100 meters, GSM is kilometers. Everyone to everyone, as per their movement, they'll connect to each other. When we are 110 meters, they connect only Bluetooth to Bluetooth. The user moves out of the 110 meters, then you'll connect to Wi-Fi. He moves out of the Wi-Fi, then you can meet the long distance communication like GSM or 5G, whatever it is. For that, we need to create the gateway based technology. Based on that, we have to devise a communication device where it can combine starting with the short distance, medium distance, and the long distance as per the availability. To have this one, we need to have the single unit up with the common antenna, cost reduced, less power consumption, size of the unit is very small, variable distance based communication of the service of voice and data communication, including multimedia. So for that particular purpose, network also need to be configured in this particular form. So for that, if you look at the protocol structure, we need to divide the same protocol structure with the various requirements of addressing, authentication, authorization, and the security by using REST protocol DSR, DSDB, AODB, TORA, ZRP, and hybrid network protocol, which combines all these things together with all networks of availability. So for that, you can create the suitable algorithm based on signal strength or based on the distances as well. So address also need to be created. The same address is not possible. We have to create different addresses that I'm not having much time, so I could explain. Sometimes later I can explain. So currently we have developed an image. For example, your device, you can create your own address by using your own face. So like that, we can create different type of addresses, and it can be generated your own address. So you need not to ask for anybody IP addresses or the mobile numbers. Your own applicate face or your own identity will be your own address, so that any number of addresses can be generated. So for that, we can create. And thank you very much, sir. Thank you for giving me this opportunity to present to you at this point of time. Thank you, Imtiazji. And I would like to thank everyone who provided this opportunity.
Sir, thank you, sir. We have a couple of questions, sir.
Yes, please, sir. Sir, first of all, I would like to do a small request. In between, there were the gap after this presentation. My suggestion to you is, please download the video and edit the gaps and reconnect and refloat, sir.
Yes, sir. Sure, sir.
Thank you. Thank you.
Okay, sir.
Please, questions, please.
Yes, sir. So, what are the features of 6G communication compared to the 5G communications?
So 5G, as I told, the technology itself is a 4G or 3G technology. Basically, 3G, 5G technology itself is a 3G partnership project. It is not the 5G. We are just extending the data rate, extending the reconfigurability by the device. So that's why we are calling it as a cognitive radio. All configurations are being done as part of the device itself. I would like to have long distance, yes, it creates the long distance. If you would like to have the short distance, it creates the short distance. Frequencies also, it varies from one frequency to other frequencies. So there is no 6G, means it's basically use case based applications. Currently 6G may not be there in very near future.
Okay, sir.
Any other questions, sir?
One more question was there. For longer distance, generally we say that analog communication is better. But in 6G, whether 5G communication or 6G?
No, sir. I would like to tell in the other fashion. Currently, there will be no long-range communication, sir, as of now, except the satellite. Now, we will not operate any long-range communication as part of the mobile communication. As part of the mobile communication, it will be very, very short distance now. So, for example, your house, you will have your own private, the 5G or the 6G base station, you will operate from that. There will not be any long distance communication except the wireless communication from one station to other station only will be the long range communication. Rest everything will be short distance communication. There will not be any requirement of long distance communication as far as mobile communication applications.
So one more question for one more participant, that the filter design will be same or different while compared to wired connections and wireless connections?
So it will be different, sir. It will be different for one application specific, sir. Basically, as a use cases, all used. For example, IoT use case for industrial will be different, medical will be different, our education will be different. What application we are trying to develop? For that, we have to use the specific filters. Accordingly, it will be adopted.
Okay, sir. Now it's time to vote of thanks, sir.
Thank you very much, sir. Thank you.
Yes, sir. Myself, Dr. Archak Praveen Kumar, Department of EC HOD, and convener to this FDP. On behalf of our organizing committee, I would like to extend a heartfelt vote of thanks for all the members who have participated in this FDP And heartfully, I would like to thank the speaker, Dr. K. Krishna Naik sir, for giving us the knowledge to gain. So I would like to apologize for any difficulties or discomforts you may have experienced during the session. Sir, we have gained so much valuable insights and knowledge on 5G wireless communications and its revolutions, mainly regarding the cognitive part and mainly regarding the wireless communication network side. So you have it's very knowledgeable for the participants to hear this. So with this, I'll end the session, sir. Thank you so much. And I would like to request the participant to share the feedback, which is so valuable for us. We will post the link in your YouTube comment sessions, or we'll send in the FDP group. I extend my thank you to all the participants. See you tomorrow in the day 4 session. Thank you all.
So, sir, one small request. After the presentation, please download, edit, and re-upload, sir. A lot of
Yes,
in between 2 times gap for there.
Yes, sir,
Water
sure.
break, okay, and 1 phone call. So,
Okay,
thank you very much, all participants. Thank you. Good day. Thank you.
Thank you, sir.
Thank you. Sir, share the link of YouTube to me also.
Yes, sir.
Thank you.
Okay, sir. Thank you, sir.